Hi everyone, I'm Cheryl. In this problem, we'd like to determine whether or not our vector field is conservative. And if it is, we're going to find the potential function. So let's begin by looking at whether or not it's conservative. We know that a vector field is conservative if the curl of that vector field is the zero vector. So we'll begin by looking at the curl. So the curl of my vector field can be thought of as a cross product, crossing the differential operator with my function f. So we're going to use a determinant form where I have I, j, and k for my first row. The second row will be the differential operator, so that will be the partial with respect to x, the partial with respect to y, and the partial with respect to z. And the third row will be the components of my vector field. So 3x squared plus yz, 3y squared plus xz, and 3z squared plus xy. So we'll begin with my vector I. And using my determinant form, I'll take the partial of 3z squared plus xy with respect to y. So everything is treated as a constant except for the y. So the derivative of 3z squared is 0, and the derivative of xy will just be x. Then I need to subtract the partial of 3y squared xz with respect to z. Again, everything is treated as a constant except for the z, so this partial will also be an x. Now I'm going to subtract my vector j, so I'll cancel out the top row and the middle column, so I need the partial of 3z squared plus xy with respect to x. So again, everything is treated as a constant except for the x, which makes this partial y. Then I'll subtract the partial of 3x squared plus yz with respect to z. Again, everything is treated as a constant except for the z, so this partial will end up being a y. Finally, I'm going to add my vector k, and I'll eliminate that first row and the last column, so I'll take the partial of 3y squared plus xz with respect to x. Everything is treated as a constant except for the x, so that is going to give me a z. And going down this diagonal, I'll have the partial of 3x squared plus yz with respect to y. Everything is treated as a constant except for the y, so this partial is going to be z. So I'll have subtract z. And notice what happens. I'm going to have 0i minus 0j plus 0k, which gives me the zero vector, which tells me that my vector field is conservative. Now that I know that it's conservative, I'd like to find the potential function. Well, what is the potential function? The potential function is a function such that my vector field is equal to the gradient of f of x, y, z. This function is referred to as the potential. So if these two are equal to each other, that means their components must be the same. So I know what the components of my function f are. They were given in my function. The components of the gradient of function f will be the partial with respect to x for the I component, the partial with respect to y for the j component, and the partial with respect to z for the k component. So let's figure out what those partials are. So we'll begin by taking the partial of f with respect to x. Since I don't know what the function f is, I don't know how to figure that out, but I know what the answer is going to be. It's going to be 3x squared plus yz. So 3x squared plus yz. The partial with respect to y, I know has to be the j component of my function f. So that will be 3y squared plus xz. And my partial with respect to z of xyz is going to be that third component, which is 3z squared plus xy. Now I need to use this information to help me get what function f is. Well, let's begin by looking at this first partial. What I'm going to do is I'm going to say that f of xyz is going to be the integral of 3x squared plus yz dx. Okay? And when I do this integral, I'm going to get x cubed plus xyz plus some function of y and z. Because when I integrate with respect to x, anything that's a function of y and z will be a constant. Okay? So this is going to be x cubed plus xyz plus a function of y and z. All right, well, that gets me part of the way. But what I'd really like to know is, what is that function g of yz? Well, I'm going to go ahead and do a little extra work here. I want to say, what is the partial of f with respect to y this time? So I'm going to leave a little space, and I'm going to look at the partial with respect to y. Okay. Looking at this, I know my partial with respect to y will be 0 plus xz plus, if I'm taking the partial with respect to y, I will have the partial of g with respect to y. Okay. I also know that the partial with respect to y, this piece, is the same thing as this, because there's my partial with respect to y. So I know that this equals 3y squared plus xz, okay? Which tells me that my partial of g with respect to y is going to be, when I add xz or subtract xz from both sides, will just be 3y squared. And notice this is the partial with respect to z. I really want to know what g is, so I'll integrate both sides, and I know then that g of yz is going to be y cubed plus some function of z. So in my original problem, I can make this a little bit more specific and say that I've got x cubed plus xyz plus y cubed plus some function of z. Okay. Now, I'd really like to find out what that function of z is. Okay. So I'm going to do a similar thing. I'm going to look at the partial of f with respect to z. I'm going to start by taking the partial of this function with respect to z. So everything is treated as a constant except for the z. So I'm going to have a 0 plus xy plus 0 plus the derivative of my function h at z. I know, though, that this is exactly the same thing as 3z squared plus xy. So I'll set it equal to 3z squared plus xy, which tells me if I subtract xy from both sides, that h prime of z is going to be 3z squared. Now, I'd really like to know what h of z is, not h prime of z. So again, integrating both sides, I know that h of z then is going to be z cubed plus some constant. So now I have x cubed plus xyz plus y cubed plus z cubed plus a constant. Oftentimes you'll see this written with the x cubed, y cubed, and z cubed together. So x cubed plus y cubed plus z cubed plus xyz plus c. This is my potential. Again, either form is correct. I hope that was helpful. Thanks.